Thank you, sir. Our sponsor, as Dr. Tweed said, is Dr. Zweifel on the College of not Engineering, Nursing. We're the College of Engineering, excuse me. And I'm Elijah Anderson.
And I'm Tate Willarius.
So a bit of background. College of Nursing is our sponsor, and we are trying to design a simulated finger for use in their glucometer lab. So what they do in this lab is they try to prick a simulated finger and get it to release a blood solution using lancet. And this is the same lancet that they are trained to use with actual human patients. So that was one of the requirements for our design, is that it uses that lancet in particular. The current solution that they have, they're quite unhappy with. It tends to leak. And in our observations with the nursing students, it was never penetrated, actually. So that's quite an issue. So our overall goal is to design a finger that's actually penetrable, is hopefully less expensive than the current solution used by the nursing department, and releases blood solution.
So here is the existing design. It's the SAFingerStick that's currently used by the College of Nursing, and they're currently unhappy with it. We sat in on a lab the other day, and if you can go to the next slide, I think it shows. No, I wasn't there, but they leak and they're hard to penetrate, as he mentioned, and filling can be difficult. If you want to go back to the filling slide. There's a very small area where the needle can actually penetrate to put solution into it. If you're not in the perfect spot, it's just dumping it into the silicone itself and not actually going into the channels. And with the current design, this one shows a clear silicone to show the filling, but the actual model is a skin color, and you can't tell really where the blood's at in it. So this is ideally what the finger should produce. If it's working correctly, being penetrated, it should show a small leak of the blood. And currently, once the finger's pricked, it can leak out of those holes if they do get it pricked. And it was pretty difficult to focus well. Here shows that this is the hole to fill it, and this is where they were actually taking the samples using the glucometer during the lab, opposed to making the hole and squeezing the blood out there. These fingers are expensive, about $50 a finger, and we'd like to optimize it to make the entire lab more beneficial to the students' education.
So our first iteration of the design was met with the introduction of a membrane over insert idea. We did this so that the insert could actually be reused from finger to finger, and then we would just recreate the penetrable membrane as it's used up. So that was one of our cost-saving strategies. This was also designed to be rotated around so that you could prick it 5 times and create 5 holes, and it would still seal around the body of the insert. And that way it saves on fabrication time, especially for a semi-hard to fabricate flexible insert. Tate has some stories about that with the senior design expo last semester, trying to print the TPU, the flexible filament. It's spaghettified in the 3D printer, and it went everywhere. It literally looked like a bowl of spaghetti with the peach-colored filament. We designed this initial one to have a pocket at the end of the finger where the blood would be stored. And that created a bit of a loose fitment that we changed in later designs. So it had some tolerance issues as well. It would crumple, and it was big and bulky. It wasted a lot of material. So moving on to our second iteration. This one has a much shorter design to save on fabrication time and save on material costs. It's a much more manageable size. It's a lot smaller. And we also, with this revision, decided to test whether or not we wanted to have an actual fingernail. And what we found is that the College of Nursing didn't really want a fingernail. They would have preferred something that would be able to be used 5 times sacrificing the more realistic or lifelike look of a fingernail. As you can see here, this one has a channel instead of a pocket at the end of the finger to hold blood. And that way there's a blood reservoir right under where the finger is actually designed to be pricked rather than having a bunch of stuff at the top. So with the third iteration, we placed a wall on the top of the channel to stop it from seeping into the top of the actual finger design. And it's now even smaller at this stage to accommodate more hand sizes. We had been testing it with our apparently giant thumbs, and we didn't accommodate for people with normal sized hands, I suppose. Apparently, not everyone is, around 6 foot tall engineer. Oh well. The membrane at this stage was finally thin enough to be punctured because we had now gone with a silicone molded membrane. The TPU was a lot thicker than it needed to be. With the TPU, since it's a 3D printed filament, the actual filament diameter that we were going with and that we had been using was far thicker than would be required to have even one layer filament around. So we had to switch to a silicone molded. And on the next slide, we'll talk a little bit about that. So the silicone that we chose is a 2-part silicone to make it very easy for nursing TAs in the nursing department to actually manufacture these membranes themselves when they're used. So then they don't have to go to a plastic supplier or go to a big company like JC3 Solutions with the SAFingerStick to get a replacement. The mold splits in half to allow easier separation. It's molded by pouring the silicone into the mold when these two pieces are stuck together, and then the mold insert, the centerpiece, is moved to create the interior diameter of the actual membrane. It uses 3mm pins to hold the actual mold insert, the center piece, in place, and those can be actually replaced with coffee stir sticks. I don't know if there's any over there, but they should at least be easy to find. And the big point behind all this is that it's user-manufacturable. It's extremely cheap. It's pennies on the dollar to create a new membrane rather than, when the old membrane breaks, it's attached to the insert and requires you to go back to the manufacturer for a $50 replacement. So that's a huge improvement in the cost area. And so last Thursday, we did some testing with the nursing students, and we found that students actually performed the lab far differently than we thought. We thought they would push the blood out in a linear fashion down the channel. And what we actually found was that they like to squeeze it on the sides when they can't get any blood out. So we're having to redesign for that. The membrane was a bit looser than intended when they did that. So the blood would actually seep around the sides a little bit. There would still be some in the channel, and some new students were able to get some blood out, which was a marked improvement over the SAFingerStick. But we're hoping to do a few design revisions as we move forward to the end of the semester. When surveyed, we have or at least I have a big stack of surveys in my apartment. 33 out of 64 students, or one more than half, preferred our model despite its flaws over the SAFingerStick. So finally, the fourth iteration, taking some of the stuff we learned from testing with the nursing students, we are moving to a slightly altered insert design. The channel is now a bunch of smaller channels so that we can get a solid surface to actually prick against when using the lancet. What we found during the testing with the nursing students was that the membrane would become concave somewhat, and that would resist actual puncturing with the lancet. So now, if we can hold the membrane in place while it's punctured and still keep a blood reservoir with this design, we can make it so the blood will still seep out while also actually being able to be consistently penetrated, which is good. Membrane has kept the same thickness as before since we had a lot of success puncturing that, albeit not with the old channel design. And we're improving some of the sealer on the insert, just increasing this length a little bit so that it doesn't seep out the back of the insert when nursing students squeeze the membrane. So here we have our decision-making matrix. We try to keep it simple with yes or no criteria. So First criteria, is it cheap? $50 is not cheap. I would not want to spend $50 on much of anything, certainly not a little piece of plastic. So the current one fails and all of ours succeed. So that's an easy one. Replaceable membrane. Ours has a replaceable membrane, the old one does not. Replaceable insert, same deal. And number of uses, the old design only has one use if you actually puncture it before it starts leaking out the membrane, whereas ours has 5, except for the nail design. Blood visible, that was touted as actually a positive. Keeping it skin colored, keeping it flesh colored was not as much of a positive as we might have thought. It was far more helpful for the nursing students to actually be able to see the blood and where it was going to actually be able to perform the lab successfully. So we kept that in our latest revisions. The has nail, I simply included that on the decision-making matrix for a visual, but that's not included in any of the scoring weighting since that was deemed to be not important. No sharp, that was a huge benefit of our design, that we don't require any sharp needle to fill, whereas the SAFingerStick might with its 90-degree fill hole. Skin penetrates, we're finally able to get that, so now our final design will be good. No leaks. Our old design leaked when, or at least our design we tested on Thursday leaked when students would squeeze it horizontally, which our new design, we're hoping that it will not leak. And it fits over finger. Once we adjusted for ergonomics, it now fits great over both the nurse students' fingers and the mannequin fingers. So that's positive. That can't speak.
So here is kind of a look at the cost analysis, and for the fingers, what we were accounting for here is 64 students twice a semester, doing a high estimate of 2 to 3 finger pokes per lab. And as you see, the SAFingerStick has $50 a finger about, and the version 2 is accounting for purchasing a 3D printer, which is also another problem with the TPU, is that they would need to purchase a 3D printer, and it is, as you mentioned, TPU is a little tougher to print than PLA. So using the silicone for the nail and the last version, we show a really good cost savings. Just the fact that silicone, especially if bought in bulk, is fairly cheap, and the inserts can be reused many times. Okay, so some of the benefits, as we mentioned, inexpensive. The leaking, as we saw with the old finger, it kind of just bubbled out, and that's where the students were actually testing from. And hopefully we'll have a tighter seal, and with the membrane being tighter, we've achieved that. Easier to penetrate. We've had to go through some revisions of making it thinner and thinner, and it's a little easier to make it thin with the silicone, as well as the TPU having a hardness of 95A and the silicone going all the way down to 15A hardness. So, and it is easier to fill without the use of the sharp and only using a blunt on the end of the needle. And is there any questions?
Sure. Could you add a standoff around your blood reservoir to create a tighter seal instead of just having a cut within your insert? Or is your silicone membrane too tight?
It's too tight right now. I believe we have to go down to 0.7 millimeters for the lancet to actually penetrate. So if we were to stretch it over, say, a standoff, that could likely cause tearing. Any other questions?
On the using that needle to fill on the old one, has anyone ever been hurt from doing that?
Not to our knowledge, no.
Actually, in the lab the other day, I think someone accidentally pricked themselves doing something. I'm not sure what, but it's more paperwork for the the advisors and just something they want to avoid in general.
Plan on doing more tests with the lab group as you guys continue to make models?
Yeah, we are. We're working to schedule some more testing after things. Yeah, use the microphone. Sorry. The question was, will we be doing more testing with the nursing students? And yes, we will. We will be doing some more testing once we get the newest revision printed, which I believe, don't we have? Yeah, so we have a new revision actually created. We just are going to do some testing with that over Thanksgiving, or not over Thanksgiving, after Thanksgiving. I'm perpetually tongue-tied. Any other questions? Mr. Cabo.
For that silicone membrane, about how long do you think it'll take for the College of Nursing to make more of them?
So I have been making the silicone membranes, and it takes honestly about 5 minutes to set up and then about 5 minutes to take apart, with just the main time being waiting for it to cure. So really not much work at the front and back end. It's just waiting and clamping multiple molds together. You can get a few at once done.
Is labor cost involved in the price per piece?
We had not factored that in. We're gonna towards the back end of this be working on timing and training with it too, and then kind of timing how long the old system was taking to fill and how long ours would be taking to make.
How many do they go through in a year? You think you mentioned it, but I forgot.
How many of ours would they go through, or the?
Yeah, of the old, yeah,
Okay.
how many prints do they do in a year or?
Yeah, so it'd be about 64 students a lab doing on average probably 2. We were accounting for 3 or more, and then that's twice a semester. So that is about 300 something.
Right, that's a lot. They haven't really gone through any SAFingersticks because they don't actually get used. They don't actually get pricked, so they tend to last forever despite all their leakages. So that's a little bit of a change. Any other questions?
All right,